Let's look at this example. The travel to work time for residents of the 15 largest cities in the United States is reported in the 2003 Almanac. Suppose that a preliminary random sample of residents in San Francisco is used to develop a planning value of 6.25 minutes for the population standard deviation. If we want to estimate the population mean travel to work time for San Francisco residents with a margin of error of 2 minutes, what sample size should be used? Assume a 95% confidence level. So this question is asking us to come up with a sample size. Okay, so we want to find the sample size n. That is what we actually want to find. That's what we want to find for this question. So what is the sample size for the amount of time, for the confidence interval to find the amount of time it takes people to travel to work? So that's what we want to find in here. So that's what we want to find. What information are we given? Well, let's go through. We are actually told that the 6.25 minutes is the population standard deviation. So the population standard deviation is this one. And we're told that that is 6.25 minutes. And what else are we told? That's the 6.25 minutes. We're told that the margin of error is 2 minutes. So let me just call that margin of error. Some books use different notations for margin of error, but it still means the same thing. Some use just E. Some even use the B, like brother. But it means margin of error. And we're also told that the confidence level is 95%, which means that alpha equals 5%. So all we have to do now is basically plug our numbers into this formula to actually find what the result is. So z of alpha over 2. Some people may be thinking now, how did he know to use this formula that he's actually putting up right now? Because he showed us two formulas earlier on, one for means and one for proportions. And you say he seems to be using the one for means. Well, yeah, I am using the one for means, and that's because the question, it actually says, is asking about the means. If we want to estimate the population mean travel to work time, it didn't ask me for a proportion, it's talking about means. So this is what I have to calculate. So we already know what sigma is, 6.25, margin of error is 2. So basically again, z of alpha over 2 is the thing that we don't know explicitly, because z of alpha over 2 is going to be z. Alpha is 5% for us for this question, so z, that's going to be z. Alpha over 2 is going to be z of 2.5%. And well, we know that's going to be a norm.s.inverse of some probability. So norm.s.inverse, and we need to put a probability in here. So what's the probability? Okay, this is the critical value, normal distribution, and z of 2.5% is this figure in here, z of 2.5%. All that means, the z means you're dealing with a normal distribution, so it's going to be normal distribution, and the 2.5% just means this area in here is 2.5%. XO works to the left, and XO actually wants the area to the left of that point, all the way down there. So if it's 2.5% to the right, then it's going to be 0.975 to the left. And so let's go over to Excel and do that. So it's going to be equal to norm.s.inverse of 0.975, close parentheses, and let's see what that comes to, 1.95, 1.96. Now again, when we go back over to here, to the actual question, we can put 1.959, 1.96, But let's just travel down a little bit more, come through with this. So the sample size n is equal to z of alpha over 2, which is about 1.96. And you just have to keep an eye out on any question you're asked to how many decimal places it wants the answer. I always like to work to the maximum amount of decimal places and then just round my answer. And so that's this. The population standard deviation is 6.25. So I'm going to put 6.25 in here. Then I'm going to divide out by the margin of error. And we're told that the margin of error was in fact 2. And we wrote that all in here. And it's all squared. So I'm going to pop back over to Excel to do it and do it as accurately as possible. So I already know what this is, 1.96, and so that was the z of alpha over 2, so I can just put z for z of alpha over 2. The standard deviation is, what was that? Standard deviation was 6.25 for this problem, 6.25, and then we have the margin of error, and that was 2 for this. That was 2 for this problem, and substituting into the formula is going to be equal to. Now we want to square everything, which means it means to raise everything to the power 2. So I can either do it in one formula, or I can do it in 2 formulas. If we do it in one formula, I can just say it's equal to, open parentheses, because I want to put a squared around the parentheses. And I can say it's going to be 1.96 times 6.25, and that's going to be divided by 2, close parentheses. Now I want to square it, which is raised to the power 2. So if I pressed Shift and the 6 key, it gives me that, which is the power key, and I put 2, and that's going to give me the answer, 37.5. So it's saying that we need a sample of 37.5 people, but remember I said we always round up, so our final answer would be 38 people. If you didn't want to solve it quite like that, raising it to the power 2, you could have just said, okay, it's going to be equal to z of alpha over 2 times standard deviation divided by the margin of error, and then you could have just squared that. You could have said it's equal to this value, raise shift 6 to the power 2, and you could have got your 37 that way. So let's just go back. So it's about 37.5 it's showing us here. So let's go back to here and say that this is actually coming to about 37.5, but we can't pick a sample of 37.5. We don't want to have a sample of 37 because 37 is not large enough. Even if this number was 37.1, we wouldn't drop down and say we want a sample of 37 because it's the closest number. We're not looking for the closest number here. We're looking for a sample that is large enough to give us the degree of accuracy that we require. So I don't want the sample to go down. If anything, I want it to be a little bit over to ensure I have the right degree of accuracy. So the actual final answer to this one is our sample size will be 38. So note again, even if this answer had come out to be, it didn't come out to be, if it came out to be 37.1, we have to round it, and we always round up, and again would say we need a sample of 38 to ensure we have the right degree of accuracy. Going up ensures we have at least the amount of degree of accuracy that we require, but rounding down will probably mean we don't have enough accuracy, the degree of accuracy that we required. And the degree of accuracy I'm referring to is if I want a 95% confidence interval, then if I round down, I might not get a 95% confidence interval as accurate as I would like. But if I round up, I guarantee that I should get at least the accuracy that I require. and probably a tiny bit more.